One of the other things we can show with the multiplex trainer is how that features can be added to a vehicle without adding any physical components. We're talking about just adding a couple lines of code to add a new functionality. And one of the things we did with our multiplex trainer is that we added in something new, which is, so we've got our pedal position here. Okay, so we've got a gas pedal, or it's not even really a gas pedal anymore because the car could be electric, the truck could be electric. So when we put the pedal to the metal, turn it up to 11, we can see our pedal position's at 100% and our speed's gonna climb right up to the max speed. Okay, so we're gonna probably get, I don't remember what the top speed is, 75 miles an hour? Probably, there we go, we're at 75 miles per hour. Now if we look here and we look at the system, we've got a choice here of engine brake. Now if this is a truck, that could mean a Jake brake, but if this is an electric car, that could mean simply regenerative braking, when you lift off the accelerator pedal and you're not touching the brakes. And depending on the rate of deceleration of the vehicle, just like when you're lift on a truck and your Jake brake applies and it starts to slow you down, well, an electric car it could be the same thing, where it's doing regenerative braking very aggressively. And if you start decelerating or braking quickly and there's a car behind you, they need to know. So we need to turn on the brake lights. So what we've done is we've programmed it when you turn on that engine brake switch, if I decelerate rapidly just by bringing the pedal position down quickly. If I do it slowly, nothing happens, but if I do it quickly, the brake lights come on. And we can use this as an example to students of how engineers, when they're developing these cars and trucks nowadays, can add functionality to a system where we didn't have to add any parts to the car or to the truck. All we're doing is a few lines of code to modify how it works based on data that's already there. And that data is already there because we have a CAN bus, because we're sharing the data. Any input to any of the modules, it broadcasted across the control area network to all the modules. So we can use that for these different features. Another thing I wanted to show you is the junction block. And we put it there, and it's in the manual, it's in the curriculum. You can use it, your students can use it, but you're not obligated to, because you could essentially, this is just jumpers. So we could jump from the end of line resistor to the DLC. We could just piggyback the different modules together rather than going through a junction block, and it'll still work. So we can create kind of a daisy chain setup. We can do a star pattern. We could, put the end of line resistor, let's say this end of line resistor right now, we've got it wired in to the instrument cluster. So it's just as if the end of line resistor was inside the module, just like in real life. So there are almost limitless combinations that you can do with the product to teach different vehicles, different manufacturer styles of wiring. One of the other really cool details that we added into the product is what a lot of people call smart switches. And this is the ability to have one input or one wire have multiple duties for, what is it trying to tell you? So this one wire, this one switch could be telling you, in this case, whether we're turning left, whether we're turning right, or the neutral position. And, each one of these values is a different voltage value that's going into the computer. And just like with the engine braking thing where we're turning on the brake lights, this is all possible because today's modern vehicles have computers that are so much more powerful. If we go back in time to when cars in the 80s and early 90s had 8-bit, 16-bit computers, they could only manage so much information. And I always love using the example of the coolant temp sensor, because on today's vehicles, you're going to have probably just one coolant temp sensor. And if you go back in time, you had a coolant temp sensor for the computer, you had a coolant temp sensor for the gauge, you had a coolant temp switch for the fan. And it was all because the computers weren't talking to each other and they weren't sharing that data. And we can explain to our students that with a modern vehicle, the coolant temp information, it goes to a module. It could be to any module, doesn't matter. It's then broadcast throughout the CAN bus network. And any of the modules on the network can pick it up and go, hey, I want to know what the coolant temp is. Well, it can check that because that data is broadcasted. So using that, we can really change kind of the way the vehicles work, and we can simplify. We can remove sensors. We can now only have one coolant temp instead of multiples. We can have one wire going for an input instead of multiple wires. So we can look at vehicles and see the results that there's going to be a lot less wiring on a car that has multiplexing than an old school car that didn't have multiplexing. So these are just some of the really cool things that I like to demonstrate when using this trainer. If you want to know more about it, check out consulab.com. If you got your own tips and tricks that you want to send in to us and have featured in the next video, just let us know. You can contact me through the website or through any of our social media outlets, either YouTube, Facebook, Twitter, or LinkedIn. Thanks for watching.